Hi students, so this is the third part of our planets and moons. So I'm going to have you go down to the formation of planetesimals and protoplanets. So how do these planets begin in the first place? Well, that's actually only hypotheses. We don't know for sure how this is happening. There's some good guesses, really good guesses, based on, and basically it's based on data that they can see, but they don't know for sure. This is not yet even at theory status. It's literally just still in the hypothesis in that stage of a hypothesis. So planets basically are believed to be thought to have started out of a disk of dust and gas that basically start around a young star and clump together by a process called accretion. And accretion is just like if you have a space or an object that's just accumulating a bunch of matter, debris, something over time. So think about something that just kind of has a buildup, like over time, unless you do something, it just gets grosser and grosser and grosser and more built up with stuff. You could look at like dust in your house just kind of builds up, or the text says like plaque on your teeth, or scaly substance on the shower. I think of it as sort of almost like the dust on your front porch, or dirt and leaves and whatever that can accumulate on your front porch. But I want you to kind of think about it as like a snowball. If you take a little, I know it's so hard for a California kids to like picture a snowball, but that white stuff that some other places get, picture a snowball, and if you just like rolled it and rolled it and rolled it and rolled it bigger and bigger, even if you roll it over, once it gets big enough, even if it rolls over some other kid's snowball, or it starts like having rolled up so much of the snow that now it's pulling up rock and dirt and everything from the ground, basically that is accretion. So accretion is just like accumulating and collecting until something gets bigger and bigger. Well, about 4.6 billion years ago, there was a giant like explosion in space, like a death of another star that basically put out tons and tons of debris into the universe. And that debris can start collecting and collecting more and more and more until the collection can get so big and heavy that it will collapse towards the center, and this causes that collapsing can cause a star, which in our case 4.6 billion years ago was our sun. And our star is really special in that we call it a sun, but there's other like main stars of different like solar systems, but our star is called the sun. And as the dust kept swirling around and accumulating, things kind of collected and got bigger and bigger, like those snowballs, except some that were smaller would run into bigger ones and kind of make that bigger ones larger and larger. Some kids play a video game like worms, like Slither.io or something like that on video games, where it's like one worm gets bigger and bigger and bigger, and it'll like, absorbs other worms along the way. That's sort of like accretion. So as that happens, the sun is collapsing towards the center and going through one process, and then the planets and the moon that we're focusing on here just keep gathering up everything in their path. They start going through that accretion process and gathering everything in their paths and getting bigger and bigger and bigger. And that's what they're saying. Pluto hasn't finished doing that yet. Pluto hasn't gathered everything in its path. And will it ever? I don't know how long it'll take to get there, but we'll see. No, we won't see because we'll be long gone. But over time, time will tell whether or not Pluto ends up gathering everything in its path. So after a while, they're basically colliding and continuing that collision process until we had the 9 planets that we have today. Okay. So once those planets had gathered, there's also a tremendous amount of heat and pressure, and all of those things can cause metals. Like the core of our earth is actually metal, but it's not a solid metal. They're pretty sure it's a molten metal, and we'll talk about how they know that later, but in the year. But basically all that pressure is making it so hot that it's like molten in the center, and as it gets hot, different layers of the earth can kind of separate and cause different elements to come together. This is a gorgeous nebula called the Horsehead Nebula because it looks a little bit like a horse. Anyways, this one is really cool. What do you think is making it dark right here out of what I just talked about there? So remember, a nebula is an explosion. First there's the death of like some kind of star, and that explodes a bunch of matter outward. This that is kind of covering up and making it dark, that's actually like a bunch of dust that's blocking the stuff behind it. So it's so heavy on debris that it's actually blocking most, not all, of the stars behind it. These must be very bright stars behind it that you can still see. And then what's all this? That is actually some radioactive material that is floating through, and that's kind of reacting, and you can see the colors there. You should look up some pictures of that if you have time. So that's all we're going to go over in this first part during this first week. But we do have a worksheet that I want you to look over, and there's another separate great video on nebula and how they form. So I explained it one way, but that video shows you with fabulous pictures and in a lot of depth to really understand how nebula gets started.